In hydrology, we learn about the hydrologic cycle and the concepts of precipitation, stream flow measurement, and how to draw a hydrograph and how to determine the discharge of flood and flood routing. These many concepts are there. Now let's see one by one concept by answering 10 questions. Now let's get into it. The line joining points of equal evapotranspiration is known as isochrones, isohyets, isobars, isopleths. So what is the term we call when the line joining points of equal evapotranspiration? Isochrones or isohyets or isobars or isopleths. So the correct answer is option D, isopleths. So what is isoheat actually? Line joining points of equal rainfall magnitude, that we call it as isoheats. When a line or a contour joining points of equal rainfall magnitude, then that will be called as isoheats. And now what is isochrones? These are nothing but line joining points of equal time of travel of runoff, to catchment outlet. This is called as isochrone. Isopluvial line means the line joining points of equal depth of rainfall of a particular written period. There is a difference between depth of rainfall and magnitude of rainfall. When the line joining points of equal magnitude of rainfall, then that will be called as isoheats. Equal depth of rainfall of a particular written period, then those lines will be called as isopluvial lines. And this is an extra point. A lysimeter is a device that will be used to determine evapotranspiration, and a phytometer is a device that will be used to determine the transpiration. And what is actually a transpiration? Transpiration is the process by which water leaves the body of a living plant. So here you can see in this diagram, water exhausts from the leaves of a living plant and reaches the atmosphere. That will be called as transpiration. And what is evapotranspiration? When the transpiration takes place, the land area in which plants stand also lose moisture by the evaporation of water. So plant also lose some moisture content by the evaporation of water in the combination with transpiration. So that will be called as evapotranspiration, and it can also be called as consumptive use. Evapotranspiration is also called as consumptive usage. So that will be determined by an instrument called lysimeter. So these are some points regarding evapotranspiration, and also there is something called AET and PET. AET and PET, nothing but actual evapotranspiration, and where PET is potential evapotranspiration. PET mainly depends upon climatic factors rather than characteristics of plants and soil, whereas actual evapotranspiration depends on the characteristics of plants and soil. So this is the basic difference between PET and AET. PET mainly depends on the climatological factors. And for a clay soil, AET to PET ratio, that is actual evapotranspiration to the potential evapotranspiration ratio, shall be unity, that is equal to 1 when the available moisture is depleted to 50%. So when available moisture, that is AW, is nearly up to 50% in a clay soil, then the ratio between AET and PET shall be unity. So this is how we can determine AET and PET. So these are some points behind the evapotranspiration. Now let's move on to second question. So this question is based on the determination of discharge in a channel. The top width and the depth of flow in a triangular channel were measured as 4 meter and 1 meter respectively. The measured velocities on the center line of the water surface, center line at the water surface are 0.2 meter and 0.8 meter below the surface, or 0.7 meter per second, 0.6 meter per second, 0.4. That is, at the surface velocity was 0.7. At 0.2 meter below the surface velocity is 0.6 meter per second, and 0.8 meter below the surface velocity was 0.4 meter per second respectively. So now we have to use the 2-point method to find the discharge in the channel. There are some methods like 2-point method, 3-point method, like that. So we have to use here 2-point method to find the discharge in the channel, discharge in the given channel by using the given data. So here answer is 1 meter cube per second. Now let's see how it is calculated. Velocity at 0.2 meter depth is given as 0.6 meter per second. Velocity at 0.8 meter depth is given as what? 0.4 meter per second. So we have to take the average of these things. So in 2-point method, we are averaging velocities at 0.2 meter depth and 0.8 meter depth only. So this is the formula for 2-point method. So we got the answer as 0.5 meter per second, and now we have to calculate the discharge. So discharge is nothing but A into V. So what is the area of the channel? Here triangular channel they have given. So that's why half into height into breadth. So what is the breadth or the top width? 4 meter. So half into height. Height is 1 meter. Depth of flow is 1 meter. So that's half into 1 into 4 into what is the velocity as per 2-point method? 0.5 meter per second. So just substitute the values to get the answer as 1 meter cube per second. Now let's see other methods. 1-point method. When we use 1-point method, we have to calculate the velocity at 0.6 meter depth. When we are using 3-point method, we have to average the velocities at 0.2 meter depth and 0.8 meter depth and 0.6 meter depth. So just calculate the average, that is sum divided by 3. So this is the 3-point method and this is the 1-point method. In this question they have asked us to use the 2-point method only, so that's why v equal to v.2 plus v.8 divided by 2. Now let's see other methods to calculate the velocities. So measurement of velocity through vertical axis meter. So there are two types of current meters. One is horizontal axis meter and another one is vertical axis meter. So current meter through vertical axis meter will be given by V is equal to A ns plus B. A and B are constants and ns is the number of revolutions per second accordingly to the units that we have followed. So ns is the number of revolutions, and there are methods behind the direct method of discharge measurement and indirect method. In case of direct method of discharge measurement, we have area velocity method, moving boat method, dilution, electromagnetic and ultrasonic methods. So this diagram depicts the area velocity method. So here subsection has to be taken in such a way that velocity over that subsection is determined, and integrating all of these subsections velocity, we will get the discharge in equal to area into velocity. So just area will be nothing but area of one subsection, and calculating all the area and all the corresponding velocity, we will get the answer for discharge. And dilution method formula will be given by q1 c1 plus q c0 equal to q1 plus q into c2. So dilution, there will be an use of tracer fluid, and by using that tracer fluid and concentration of the tracer fluid as C1 or C0 correspondingly, we can calculate the discharge value by using this formula. And indirect methods are two things: flow measuring structure like weirs, notches. By constructing those things, we can calculate the discharge value. And there is another thing called slope area method. So these many methods are there to determine velocity and discharge in a channel. Now let's move on to third question. The rainfall on 3 successive 2-hour storm period in a catchment were measured as, so 0.5, 2.5, 1.6 centimeters. So 3 successive 2-hour storm period is given if the total runoff at the outlet from the catchment was, so total runoff is given as 3.2 centimeter. The value of phi index. So we have to calculate the phi index. Phi index is related to the infiltration. So that means it is a loss. We have to calculate the phi index based on the given data. Here the answer is option B, 0.3 centimeter per hour. Now let's say how it is calculated. First step is to summing up all the precipitations. So what are the precipitations given? 0.5 centimeter and 2.8 and 2.6. So sum total of the precipitations as 4.9 centimeter. And what is the total runoff? 3.2 centimeter they have given already. And we have to calculate the individual intensities, individual 2 hour storm period intensities. So I1 is 0.25 centimeter per hour. How it is then? 0.5 centimeter in first 2 hour interval. So divided by 2, that gives the 0.25 centimeter per hour. Similarly, 2.8 divided by 2, 1.4 centimeter per hour, and 1.6 divided by 2, 0.8 centimeter per hour. So we have calculated the three intensities. So how much total time taken to get the precipitation of 4.9 centimeter? 2 plus 2 plus 2, 6 hours. So in a 6 hour duration, we will get a total precipitation of 4.9 centimeter and total runoff of 3.2 centimeter. And how to calculate the pi index? Pi index is nothing but P minus R divided by T. So we know the value of P, 4.9, and R, that is runoff as 3.2 divided by total time 6. So we got the phi index value answer as 0.283 centimeter per hour. But this is not the actual phi index when because only the phi index less than the I1. That is, only when intensity of rainfall is greater than the phi index, then that will give the runoff value. Here you can see I1 and phi. So I1 is 0.25, but phi index is 0.283. That means phi index is greater than I1. That is not possible. So that's why I1 is disregarded. That means I1, that is intensity of rainfall at first 2 hour period, will not give runoff, will not uh, give the runoff value. So that's why intensity 1 is neglected. So that's why 4.9 minus 0.5. 0.5 is the what? First interval precipitation in first interval. That is minus, that is taken off, and minus 3.2 divided by 6 minus 2. So the first 2 hour is taken off. So that's why we will get the answer is 0.3 centimeter per hour. Now this value will be less than I1, I2 and I3. I1 not, I2 and I3. That means I2 and I3 will possess runoff value, will contribute some runoff. So this is how we have to calculate the phi index. And the phi index formula is nothing but P minus Q by T. So we have already seen. There is another thing called W index. W index is given by P minus R minus initial losses. So IA is initial losses divided by T. So that's why W index shall be less than or equal to phi index. So W index is always less than or equal to phi index, because we are also taking initial losses into account in case of W index. So that's why W index shall be less than or equal to phi index. And there is another important thing regarding infiltration, Horton's infiltration equation. Fp is equal to Fc plus F naught minus Fc e power minus knt. So this is the basic Horton's equation. So Fp is nothing but infiltration at time t, and Fc is the maximum capacity, infiltration capacity, and F naught is the initial infiltration capacity, and Kn is the infiltration coefficient, and T is the time duration. So accordingly, we will get the value of Fp. So actually Kn is nothing but decay coefficient of Horton's decay coefficient. We call Kn as Horton's decay coefficient. So these are the some important points regarding infiltration equation. So here you can see the graph of infiltration, Horton's infiltration equation. So graph will be like this. It will be decaying, and it will be asymptotic to the horizontal curve time, horizontal axis time. This is the F naught value, that is initial infiltration, and Fp is the infiltration at any time that we require, and Fc is the Rf infinity. F infinity is the maximum infiltration capacity of that area. So this is the basic Horton's curve. Now let's move on to fourth question. A tropical cyclone is a low pressure zone that occurs in the northern hemisphere only, or high pressure zone with high winds, or zone of low pressure with clockwise winds in the northern hemisphere, or zone of low pressure with anti-clockwise winds in the northern hemisphere. So what is the correct definition of a tropical cyclone? So correct definition of a tropical cyclone is option D, zone of low pressure with anti-clockwise winds in the northern hemisphere. So let's see more about precipitation and cyclones. So there are three types of precipitation happening. One is orographic, another one is convective, and another third one is cyclonic. So orographic precipitation is a type of precipitation that will occur when moist air mass may get lifted up to higher altitude. So that means it will be occurring in a mountain or a hillside region in windward side. In leeward side there will be dry case. So very often very little precipitation will be there in leeward side. So just when we draw a diagram, this is windward side and this is leeward side. Precipitation shall be in the windward side only, and in leeward side there will be very little or no precipitation. So this type of precipitation is called as orographic precipitation, and in India most of the precipitation occur due to orographic precipitation only. And next one is convective precipitation. It is caused due to pocket of air is warmer than surrounding air. So when some pockets of air is warmer than the surrounding air, then that will be called as convective precipitation. This occurs in the form of high intensity showers but in shorter duration. Showers will be of high intensity but duration will be very short. And next is cyclonic precipitation. So we have already seen cyclone is a large low pressure region with circular wind motion. So large low pressure region with circular wind motion, and it will be anti-clockwise and occurring in the northern hemisphere. So this is the cyclonic precipitation, and there are many types of cyclone. One is tropical. Actually tropical cyclone is the anti-clockwise direction in the northern hemisphere. And in case of extra tropical, there is another thing called extratropical. Extratropical cyclone cyclone occurs outside the tropical zone of the world, so that's why it is called as extratropical. So this cyclone occurs outside the tropical zone of the world. And this type of cyclone also possesses a strong anti-clockwise wind circulation in the northern hemisphere. This is also similar to tropical but occurs outside the tropical zone. And next is the anticyclone. Anticyclone occurs with a clockwise direction in the northern hemisphere. So anticyclone means clockwise direction, clockwise circulation in northern hemisphere. And next is a frontal cyclone. Frontal cyclone means that occurs when a warm air mass and cold air mass meet under favorable conditions. So for example, let's say uh, in this side a warm air mass is occurring, in this side a cold air mass is occurring. So at the mixing point, when a favorable condition exists, then a cyclonic happening will be there, so that will be called as frontal cyclone. So these are some important types of cyclone regarding precipitation: tropical, extratropical, anticyclone, and frontal cyclone. And how we measure a measurement of precipitation using rain gauge. Rain gauge can also be called as umbrometer, hydometer, odometer, and pluviometer. And the location of rain gauge should be in such a way that it should be surrounded by at least a 5.5 meter square area at least. So no object should be nearer to the instrument in a radius of 30 meter, and the height of the object should be less than 2 times the 2h. That is 2 is the height of obstruction. And there is something called snowfall measurements will be done by using snow stakes, snow gauge, and snow tips. Snow stake is used to calculate the depth of snowfall, and snow gauge and snow tubes are used to convert the snowfall into water equivalent, so that we can calculate the snowfall precipitation. And there are recording and non-recording type of rain gauges. And non-recording gauges example is Simon's rain gauge, and but it is obsolete now. it is not it is very obsolete, no usage. And recording rain gauges, example tipping bucket, weighing bucket, and natural siphon. So these three rain gauges are called recording rain gauges. And tipping bucket rain gauges are installed in hilly and inaccessible areas. Tipping bucket is usually installed in hilly and inaccessible areas. And the weighing bucket type and natural siphon type uses it provides mass curve rainfall, mass curve of rainfall, weighing bucket and natural siphon. So these are the some important definitions and concepts behind the precipitation. Now let's move on to the question. There are four rain gauge systems existing in the catchment of a river. The average annual rainfall values at these stations are 780, 640, 400, 520 mm. So four values or rainfall values are given. We have to calculate the optimum number of rain gauges by allowing a percentage of error 10%. So what will be the optimum number of rain gauges? So there are three formulas to be followed here. By using those three formulas, we can get the answer for optimum number of rain gauges. So here answer is 8. So first step is to calculate the average rainfall. So P bar is equal to sum of the rainfall divided by total number of rainfall recorded. So here four rainfall values are there. So sum of the four values divided by 4, that will give answer as average rainfall answer is 585 millimeter. And sigma n minus 1 is the standard deviation. Standard deviation is given by summation of pi minus p bar the whole square. What is pi? Pi is precipitation at ith gauge. That is p1 means 780, p2 means 640, p3 400, p4 520 minus the average. So average we have found as 585 mm. So summing up all the things and also squaring and divided by n minus 1 will fetch the answer as sigma n minus 1, that is standard deviation value as 162.178, 162.78. And next step is to calculate the coefficient of variation. So that will be given by cv is equal to standard deviation divided by average rainfall into 100. So cv value is presented in percentage. And finally we are calculating the optimum rain gauge, optimum number of rain gauges. So capital N is equal to cv by epsilon the whole square. So cv epsilon, we know epsilon is error. Usually error allowed is 10%. So just substitute over here and square it to get the answer. Here answer is 8. So this is how we have to calculate the optimum number of rain gauges. So first step mean rainfall, second step standard deviation, third step coefficient of variation, and fourth step is the final formula n, optimum number of rain gauges. Now let's see other things about the number of rain gauges. So as per IS 4987, optimum density of rain gauges in plain area shall be this much, one station per 520 km square. In areas having elevation of 1000 meter, there we will give one station per 260 to 390 km square. And in case of hilly areas having heavy rain, one station per 130 km square. So high density of rain gauges will be there in hilly areas and very low density in plain regions. And how to estimate missing data? There are two methods. One is arithmetic method and another one is normal ratio method. We use arithmetic method when the variation between the data is less than 10%, is less than 10%. For example, we are calculating the average one. So that average will be less than the 10% of all this value. Then we can go for arithmetic method, or otherwise we have to go with normal ratio method. So normal ratio method formula goes like this: Px is equal to nx by n into p1 by n1 plus p2 by n2 and goes on. And what is N1, N2, N3? These are normal precipitations at the corresponding station 1, 2, 3, etc. And what is Nx? Nx is nothing but normal precipitation at the station where the data is missing. So this is the Nx value. And P1, P2, P3 we know the values. And Px also actually px to be found out, that is the mixing rainfall data. So this is how we have to calculate the missing rainfall data using normal ratio method in case variation is greater than 10%. If it is less than 10%, we can go for simple arithmetic mean method. So these are some important things regarding rainfall, precipitation and rain gauges. Now let's move on to sixth question. Estimate the average daily evaporation from the deep lake reservoir of relative humidity 50%. So they have given relative humidity, saturation vapor pressure is 32 mm of Hg, wind velocity at 1 meter above the ground level is 14 km per hour. We have to calculate the average daily evaporation from the deep lake reservoirs. So here Meyer's formula has to be used. Meyer's formula has to be used so that we can get the value of average daily evaporation. Answer is 12.6 mm per day. So here Meyer's formula goes like this. Evaporation, that is E is equal to K suffix m into ES minus EA into 1 plus U9 by 16. So what is Km? Km is a constant, depends on the condition. Here they mentioned as deep lake reservoir. So that's why Km is 0.36. And in case of shallow water, Km shall be 0.5. So 0.36 for deep water and 0.5 for shallow or small shallow water. And what is U suffix 9 here? U suffix 9 means monthly mean wind velocity up of about 9 meter above ground level. So it is monthly mean wind velocity of about 9 meter above the ground level. So for example, if it is the ground level, then above the 9 meter level, what will be the wind velocity? That is denoted as U9. And what is ES and EA? EA is nothing but it is vapor pressure measured at same height at which wind speed is measured. If the wind velocity data would be available at an elevation other than the needed, then we have to find the velocity using 7th power law. So what is 7th power law? U at h is equal to C h power 1 by 7. C is constant. So here they have given the relative humidity value. Relative humidity is given as ratio of EA by ES. So therefore we can calculate the value of what? EA. Because they have given the value of saturation vapor pressure. ES is 32 mm. Then what is EA? Just substitute here so that we can get the value of EA. So we got ES, EA, KM and also the U9. U9 value is not there because we have only the velocity 1 meter above the ground level. So by using this relation we can get the value of U9. How? U1 divided by U9 equal to H1 divided by H9 power 1 by 7. What is H9? Actually, this is 1 and this is 1 by 9. Wait 1 minute. Actually, 1 meter height and at 9 meter height. By using 7th power law, we can get the answer for U9 value, and by substituting all the things, we get the answer as E is equal to 12.65 mm per day. So this is how we have to find the evaporation, daily evaporation using Meyer's formula, E equal to Km into ES minus EA into 1 plus U9 by 16. And now let's see more things about evaporation. Evaporation measurement can be done by using these devices: Class A pan, ISI standard pan, and Colorado sunken pan, and US Geological Survey pan. Every pan has its unique dimensions and lake CP value, that is pan coefficient. So lake evaporation will be given as pan coefficient into pan evaporation. So that's why CP is always less than 1. So that means pan evaporation is greater than lake evaporation. And the next one is evaporation station density. Similarly, rain gauge density, we have to install the evaporation stations with the density like this. For arid zones, 1 per every 30,000 km square, and in case of humid zones, 1 per every 50,000 km square, and in case of cold regions, it will be 1 per every 1 lakh km square. So this is the evaporation station densities. And there are some methods to evaluate the evaporations. One is analytical method. In analytical method, there are three methods: water budget method, energy balance method, mass transfer method. So this diagram gives the energy transfer method. So this diagram gives the energy transfer method. So this is a pond or lake on which solar radiation is happening with the heat Hc, and this will be ingressed with the 1 minus r into Hc. And what is r here? R is reflection coefficient. So r into Hc is reflected, and H suffix b is back radiation. And heat influxed into the ground is denoted by Hg, and heat stored is denoted by Hs, and advection heat is given as Hi, and evaporation loss is rho L into El, and Ha is the heat loss to the air. So these are the terms involving in the analytical method of energy balance to calculate the evaporation loss. Here L is the latent heat, and there is something called Bowen's ratio. The belief denoted as beta, that is the ratio of Ha divided by He. Ha divided by He. So what is actually Ha? Heat loss to air. And what is He? What is He here? He is rho L into El. That is heat energy used in evaporation. So Ha we know, heat loss to air. He is rho L El. That is the He. This is called as Bowen's ratio. This is an important term regarding energy balance method. Now let's see how to reduce the evaporation loss. This can be done by using cetyl alcohol and stearyl alcohol. By using chemicals, these two chemicals that form monomolecular layers on a water surface. So we can use cetyl alcohol and stearyl alcohol as a chemical cover to reduce the evaporation loss. And there is something called evapotranspiration, and the equation is given by Penman's equation. So potential evapotranspiration is given as PET equal to AHN plus EA gamma by A plus gamma. And what is capital A? Capital A is the slope of saturation vapor pressure versus temperature curve. So when we draw a curve between saturation vapor pressure, that is ES, and the temperature, that's we get a slope, and that slope is taken as capital A. This will be in terms of millimeter of mercury per degree Celsius. And what is H suffix n? H n is the net radiation. So net radiation will be in millimeter of evaporable water per day. And what is EA? EA is a parameter that will include wind velocity and saturation deficit. And gamma is the psychrometric constant. Psychrometric constant is usually 0.49. 0.49 mm of mercury per degree Celsius, and other things like that's it. AHN plus EA gamma by A plus gamma is the potential evapotranspiration as per Penman's equation. So these are some concepts behind evaporation and evapotranspiration. Now let's move on to seventh question. The peak flow of a flood hydrograph caused by isolated storm was observed to be 120 meter cube per second. The storm was of 6 hours duration and had a total rainfall of 7.5 cm. Base flow is given as 30 meter cube per second, and phi index is given as 0.25 cm per hour. The peak ordinate of 6-hour unit hydrograph is. What is the peak ordinate of 6-hour unit hydrograph? They have given many things like base flow value, peak flow of a flood hydrograph as 120 meter cube per second, and also the total rainfall, and also the infiltration loss, that is phi index value as 0.25 cm per hour. By using all these values, we have to find the peak ordinate of 6-hour unit hydrograph. So here the answer is 16 meter cube per second. Now let's see how it is calculated. First, we have to calculate the loss due to infiltration in centimeter. They have given in terms of centimeter per hour. So here 6-hour flood hydrograph, 6 hours storm duration. So that's why 0.25 into 6. So this is the loss. This is the infiltration loss. So how to calculate the effective rainfall? Total rainfall minus the infiltration loss. So effective rainfall is 6 centimeter. So now we have to calculate the runoff. What is runoff here? Actual discharge minus the base flow. Actual flood discharge, that is 120 cubic meter per second, minus base flow. So 120 minus 30 gives that 90 meter cube per second. This runoff is actually calculated for a 6-hour storm hydrograph. 6-hour storm hydrograph, but we require the unit hydrograph. So therefore 90 by 6. What is mean by unit hydrograph? A hydrograph having 1 centimeter base flow, 1 centimeter runoff. Actually 1 centimeter runoff is the what? Unit hydrograph. So that's why 90 by 6. Actually effective rainfall of this 6-hour unit hydrograph was 6 centimeter. Now we require only 1 centimeter, that is unit hydrograph. So that's why 90 by 6 gives the answer as 15 meter cube per second. So actually not 16, 15 meter cube per second answer. So here in this diagram you can see actually this is the base flow. This is the base flow happening here, and this is the peak discharge value, and time of concentration, point of inflection, resistance limb, rising limb. We will see now. What is rising limb? Rising limb is looks like this, and this will be affected by climatic factor only. And in case of recession limb, that will be affected by physiographic factor. So there is a difference. Rising limb will be affected by climatic factors, and the resistant limb will be affected by physiographic factor. And what is base flow separation? Now we have already seen this is the base flow. We have to separate accordingly with correct calculation. So there is a method called straight line method. So straight line method means we have to calculate the n value. So n value is from the peak to the end point. So this is the n value. N value is given as 0.83 a power 0.2, where a in kilometer square. 0.83 into a power 0.2. And what is effective rainfall? Effective rainfall is direct runoff volume divided by catchment area. It is simple. And what is DRD? Direct rainfall depth. So direct runoff depth will be given as 0.36 into summation of the ordinates into T divided by A. So what is actually O? Ordinates of direct runoff hydrograph, DRH. O are the, that is ordinates of DRH, that is direct runoff hydrograph. So when we need DRD, that is direct runoff depth of a unit hydrograph, then we have to calculate the ordinates of unit hydrograph. So how to calculate that? U is equal to ordinate of storm hydrograph divided by DRD. That will give the answer for ordinates of unit hydrograph. What is unit hydrograph actually? We have to calculate the runoff into runoff. We have to calculate the discharge for 1 centimeter runoff. That is the unit hydrograph. And there are some assumptions in unit hydrograph theory. One is time invariance, and another one is linear response. What actually is the time invariance? The runoff produced from a given discharge basin or a given drainage basin due to a given effective rainfall. That will always be the same irrespective of the time of its occurrence. That is runoff produced from a given drainage basin having same irrespective of time of its occurrence. So that is the time invariance. And what is linear response? It is nothing but if a 4-hour unit hydrograph due to 1 centimeter rainfall is given, then a 4-hour hydrograph due to 2 centimeter rainfall would just mean the doubling the unit hydrograph ordinate. This is the linear response. That is linearly varying with respect to the duration. And another curve is called S curve. S curve is given as continuous rainfall at a constant rate for a infinite period. So S curve looks like this. So this is the continuous rainfall at a cumulative rainfall curve, that is continuous rainfall at a constant rate for an infinite period. There is no bar in time period. This is when we draw in such a curve, that will be called as S curve. That curve is in the shape of S shape. And for S curve, there will be equivalent discharge. How to calculate that? QS is equal to 2.778 into A by D. D is the duration in hours. A is area in kilometers square. And other graphs are such as distribution graph, synthetic unit hydrograph, triangular unit hydrograph, dimensionless, and instantaneous unit hydrographs are there to calculate the runoff value. So these are some basic concepts and important concepts behind the hydrograph and unit hydrograph. Now let's move on to eighth question. Muskingum method is used in hydrologic channel routing, hydraulic channel routing, hydrologic reservoir routing, or hydraulic reservoir routing. So this question is based on flood routing. Here Muskingum method is asked. Muskingum method is used in what type of routing? This is used in hydrologic channel routing. Now let's see more about this. Hydrologic channel routing has a storage which is a function of inflow and outflow. So S is a function of I and Q. And there are two types of storages. One is prism storage and another one is wedge storage. You can see in this diagram what is prism and wedge storage. Prism storage is nothing but the volume formed by an imaginary plane parallel to channel bed. So imaginary plane parallel to channel bed and drawn upstream from the outflow section to the inflow section. That will be called as prism storage. And what is wedge storage? Whatever the volume above the prism storage is called as wedge storage, and it will be in the shape of triangle. It is the triangular volume enclosed between actual water surface profile and the top surface of the prism storage is called as wedge storage. And the total storage value will be given by using this relation k into xi power n into 1 minus x q power m. So what is q, sorry, what is k x and 1 minus x, we will see later in case of Muskingum. In case of Muskingum equation, m is 1, and what is x? X is the weightage constant and k is the coefficient parameter and m is the constant exponent. So this is coefficient parameter, this is constant exponent, and x is the weightage parameter in case of prism storage and in case of wedge storage. And for Muskingum equation, relation goes like this: Q2 is equal to C0 I2 plus C1 I1 plus C2 Q1, and summation of all the coefficient value will be equal to 1. Summation of all the coefficient value will be equal to 1, that is C0, C1 and C2. And how to calculate C0, C1, C2? Using these three relations. C0 will be minus kx plus 0.5 del t by k into 1 minus x plus 0.5 del t. Similarly, C1 and C2. And these are something related to hydrologic channel routing. And there is another thing called reservoir routing, and that will be found by using these three methods: modified pulse method, Goodrich method, and Runge-Kutta method. And Sen-Vanant's equation gives the actual flood routing equation, and this Sen-Vanant's equation is related to the basic equation used in flood routing. What is the basic equation? Nothing. I minus q is equal to the change in storage with respect to time. And by based on this equation, we got this Sen-Vanant's equation of motion for a flood wave in terms of partial differential equation or partial differential functions. And these are the important things regarding flood routing. And this graph gives some terms like peak attenuation and lag time. What is peak attenuation? Difference between a maximum peak inflow and peak outflow. And the lag time is the time difference between the peak inflow and peak outflow. The time lag due to occurrence of peak inflow and peak outflow is the lag time. And these are the some important and basic terms regarding flood routing and Muskingum method. Now let's see ninth question. Which of the following are correctly matched? Dicken's formula is given as Q equal to CD A power 3 by 4, and Ryve's formula, Inglis formula, and greatest rainfall, probability of greatest rainfall. PM, that is greatest rainfall centimeter. All the options are correctly matched. Now let's see more about flood frequency and also other things. Flood frequency analysis is given by using this equation. Probability of flood frequency is m by n plus 1. Now before moving to these notes, let's see the definitions of the options. Dicken's formula is given as q equal to CD a power 3 by 4. And this Dicken's formula is mainly used in northern parts of India and also central parts of India. And A is catchment area in kilometers square. And Ryve's formula is basically used in southern parts of India, mainly Tamil Nadu, and A also here in kilometers square, a power 2 by 3. And Inglis formula is mainly used in Western Ghats, 124A by root of A plus 10.4. The greatest rainfall will be given by PM is equal to 42.16 d per 0.475, and d is the duration in hours and PM in centimeter. So these are the important things. And now let's see the other nodes. And probability in case of flood frequency analysis, m by n plus 1. What is m? Rank of that flood and divided by n plus 1, total number of flood plus 1. This is the probability of occurrence of that flood. And recurrence interval is given by reciprocal of probability. And probability of occurrence of rainfall r times in n consecutive year is given by binomial equation NCR p power r q power n minus r. And when at least once in n consecutive year, that means it is called as risk. And that risk probability will be given by p is equal to 1 minus q power n. And what is q? Probability of non-occurrence. Q is 1 minus p. 1 minus p is q. And there is another thing called reliability. Reliability is 1 minus risk. And these are the some things regarding probability of occurrence of rainfall. And this is called Gumbel's method regarding flood discharge value. And xt is equal to x bar plus k sigma n minus 1. And sigma n minus 1 is standard deviation that will be given by using this formula, x minus x bar the whole square divided by n minus 1 the whole root. And squaring it, we will get the variance. And what is k? K is given by yt minus yn bar divided by sn. And what is yt value? Yt value is minus what is natural log into natural log t by t minus 1. What is t? Recurrence interval. And when n tends to infinity, we will get sn value as 1.2825, yn bar as 0.5777. So these are the terms involving in Gumbel's method. Now let's see the last question, 10th one. Match the following. So how every parameter is calculated and how every parameter is presented in terms of graphs. Rainfall intensity, excess, averaging, and the mass curve. Now let's see the answer. Rainfall intensity is related to hydrograph. So in hydrograph we use the rainfall intensity, that is centimeter per hour or mm per hour or like that. And rainfall excess is related to direct run of hydrograph. Rainfall averaging is related to isohyets. And cumulative rainfall in mass curve we use the cumulative rainfall value. Let's see the more things about precipitation. When we want to calculate mean precipitation value, we can use three methods. One is simple arithmetic mean method. Next is Thies and polygon. Another one is isohyet methods. Thies and polygon methods goes like this: PM is equal to summation of PI AI by A. In Thies and polygon method, we will divide a catchment area into some polygons and find the area of those polygons and corresponding precipitation. So Pi into Ai divided by total area of the catchment. So this is how Thies and polygon methods goes. And isohyet method, isohyets are the lines joining points of same rainfall intensity. So Pm is equal to P0 plus P1 by 2 into A1, and summation of all those divided by total catchment area. This is the isohyet method. This is how we will calculate the mean precipitation or average precipitation. Now let's see the drought condition. There are two conditions of drought: meteorological drought and hydrological drought. Then is another drought is also there, agricultural drought. Agricultural drought is related to the evapotranspiration. So that will be given by PET minus AET by AET. That is the agricultural drought. And now let's see the main part, meteorological drought. When greater than 25% decrease in precipitation happens over a catchment area, then that will be called as meteorological drought. When it is more than 50% deficit, that will be called as severe drought. And when an area of 20%, when more than 20% of an area affected with a decrease in precipitation, then that will be called as drought year, and that year will be called as drought year. And probability 20% to 40% lies within the range, then that area will be called as drought prone area. When that probability or that precipitation happening is greater than 0.4 percentage or 0.4 40%, then that will be called as chronologically drought prone area. And in case of hydrological drought, it will be affected by magnitude, duration, severity, frequency. These are the some concepts and terms behind drought. Now we are at the end of this video. If you like this video, please like, share, comment, and share with your friends also. Thank you.